Hello.
Hello, Matt.
Okay, let's start. Let's start new unit, right? Do you want to ask anything?
Nothing, Matt. Ma'am, you
Okay,
didn't upload the study material.
okay. Can you? Pardon, I'm not getting you. Do you want to ask anything? Uh,
Ma'am, you didn't post the study materials.
okay, so okay. You are saying about me. Yeah. You can see after some time. I did it, but after some time you will able to see that. Okay.
You'll post it on.
Yeah. Yeah. Sure. Otherwise, I'll send you on WhatsApp. After some time, you can check it. If you will not able to see that, then I'll send you on WhatsApp. So today we'll start next unit number fourth, probability and distribution, right?
Yes, ma'am.
Okay. So let us understand. Do you know anything about probability? Something? Do you know something about probability?
Mm.
Okay. So let's start with the basic. Right.
Now you're
So
doing like
probability.
10:30 with Arjun, right?
Yeah.
10
10 at 10.
So I was not like,
Okay, it's okay. So probability means a possibility to happen any event. Like when we toss a coin, then there are two possible outcomes. One is head and another is tail. Okay. So
king and
yeah, in deck of card. So let us
red
understand
card.
the probability. Yes, first we will understand what are outcomes, what are events. Okay. After that, we will know about the probability as we are doing from the basic. Mm. So, what no, what mean it by outcomes? When we toss a coin, a single coin, then outcomes when we toss a coin. Then outcomes are head or tail. There are two outcomes. Okay. When we toss two coins, we toss two coins, then possible outcomes um head, it may possible head or tail on both coins. In one coin it can have head, another one can have tail, and first can have tail and another can have head when we toss two coins. So these are possible outcomes. Okay. And what a sample space, we put these all outcomes in brackets, this bracket, sample space. Sample space is denoted by S. And when we put all possible outcomes in this bracket, then this is called sample space. When we toss two coins, then sample space is head, tail, head, tail, head. And when we toss two coins together, three coins together, then a sample space can head, tail, tail. We'll do question related to the this. That's why we are doing from the basic, okay? And next can with two hats outcomes can um hat, tail, hat, and tail, hat. Next, with one hat, tail. We have to take all possible outcomes. That's why we are taking all. Tail, hat, tail, and next one is tail, hat. So these are all possible outcomes. It can have single one like this. Single means okay, either only had on all three, either all tail, or on all three. With two had one tail, with two had one tail, with two had one tail, with one had two tails, with one had two tails, with one had two tails. So there are all possible outcomes. Okay. Mhm. So this is the sample space when we toss three coins together. So let us understand what is the possibility when we find. Mhm. Wait, probability means formula to find probability is equal to number of favorable favorable outcomes over total number of outcomes over total number of outcomes. This is the formula to find probability of outcomes. Okay, so if we toss one coin and probability to find had in this case, so favorable case to find had is only one and total outcomes are two. So probability to find had is 1 upon 2 because we have only one favorable outcomes and there are two total outcomes. Okay, in this case if we need to find a probability to get two hats, so how many favorable outcomes, let's see. There are with two hats, one, two, three. Okay, so write down here three. And how many total number of outcomes are there? One, two, three, four, five. Let me one, two, three, four. 1 second. There is some screen problem. There are eight. One, one of all three, and three of two hats, one tail, and two tail, one hat. So there are eight total outcomes. If we toss three coins together, so write down here eight. So this is required for probability P to find two hats. If you find to get three hats in this case, three hats, so there is only one favorable cases and total number of is eight. So one is favorable and total numbers of outcome is eight. So probability to find three hats together is 1 by 8. Got it? Got it means of probability?
Yes, ma'am.
Hello? Yes.
Yes, ma'am.
Yes. Okay. So now let us do for to throw a die. Now we have done the four coin. Now let us do for dice. Okay. Hmm. So when we throw a die,
No, but
then possible outcomes. One second. Wait. Hmm. So possible outcomes are when we throw a die, then possible outcomes are it can one, two, three, four, five, and six. And so sample space as is this. Okay, so this is the sample space. Now let us find the probability related to this condition. If we need to find a probability to get a prime number, okay, so there are three prime numbers, 2, 3, and 5. They are prime numbers. So probability to get a prime number is to get a prime number. There are three prime numbers, so three are favorable outcomes, and total number of outcomes are six. So let's six here. So probability is three ones are three twos are. So this is 1/2. Okay, and we have to find probability to get only one, get or one on a face. This only one. So this is only one favorable outcome, and total is six. So probability to get one is probability to get one is equal to 1 upon 6 because we have only one time in sample space. Got it? Hmm. So let us do for the condition when we throw two dice together. Two dice together. Are you getting me?
yes, ma'am.
Okay, two dice together. So what are the possible outcomes? Let us find it first. Okay, so it can have on the faces of two dice, it can 1 comma 1 together, one on one face, two on other face, and one can have on one face and three on another face. Similarly 1 comma 4, similarly 1 comma 5, and one another condition is 1 comma 6. And similarly in second condition it can have two on first face and one is second. 2, 2, 2, 3, 2, 4, 2, 5, to 6. Next, it can have 3 on first and 1 is second, and similarly 3 comma 2, 3 comma 3, 3 comma 4. Next one 4 comma 1 and 4 comma 2, similarly 4 comma 3. Similarly 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5, sorry 5 and 5 comma 6. Similarly 6 comma 1, this is the last condition, 6 comma 2 and 6 comma 3 comma 4, and next one is 6 comma 5 and 6 6. And if you find sample space, then just put these all outcomes in this bracket. So this is sample space. Now we need to find probability to get sum of 10 or as a 6, any number like which include in this sample space. Okay, that we have to find sum of probability, for example, to get sum 10. Okay, for example, so what are the possible all possible outcomes to get 10? So let's see, in first there's no condition to get 10 because this is the maximum value. When we add 1 plus 6, then we'll get only 7. So there is no condition such. We get 10. Here is one condition to get 10. 4 plus 6 is 10. Here 5 plus 5 is 10. And here 6 plus 4 is 10. Third condition, yes. So there are three favorable cases. This one to get sum 4 plus 6 is 10. 5 plus 5 is 10, and here 6 plus 4 is 10. So there are three favorable cases and total number of cases are 36. So probability to get some 10 is 112. So probability is 1 upon 12. Got it? Hmm. Now next, if we need to find probability to get some as 8, as 8, then you can find here one case to find 8, this one also 8, and this one to find 8, and this is also how many mm, favorable cases? 1 2 3 4 4 5. Correct. So there are 5 favorable cases to get some 8. Probability to get some 8 is equal to, there are 5 favorable cases, and total numbers of outcomes. Five is favorable outcomes, and this is total number of outcomes. So this is the required probability. Got it? Hmm. Okay. So can you send me your own questions? Do you have any material or PDF like questions? Do you have?
Find the probability of getting it in toss of coin.
Yep. So I'm asking you, do you have your own questions? I
No, ma'am.
just do. Okay, you don't have. Okay, let me open my questions. Okay, and tell you. Wait a minute. Wait a minute. Hello, Divya. Next, you need to do distribution, probability distribution. So you need to learn permutation, or like factorial value to find factorial value, permutation, and combination. You need to learn. So let us start for this topic. Okay. Hello.
Hello.
Do you know that? Yeah. Do you know about factorial value or permutation combination? Do you know that?
No, ma'am. No, ma'am.
Okay, so let's start to find factorial value because this is needed for next probability distribution. So let us understand that. Mm. So permutation. Mm. Sorry, first of all, learn factorial value. Factorial. Factorial means formula is factorial n. N means take any number. This is equal to n, n minus 1 into n minus 2 and up to 3 into 2 into 1 till to 1. Okay, so let's suppose n is equal to 5 and you need to find factorial 5. So factorial 5 mean is equal to 5 into 4 into 3 into 2 into 1 is equal to 120. Similarly, we need to find factorial 4. This is 4 into 3 into 2 into 1. Got it?
Got it.
Factorial 3 is 3 into 2 into 1 is equal to 6. And this is the rule, factorial 0 is equal to 1 and factorial 1 is equal to also 1. So these are the rules to find factorial value. Got it? Okay, so let's start with the now permutation. Permutation means number of arrangements. Number of arrangements. Okay. Mm, of are things from taken from n total things. Okay, let us understand, like if we have 26 letters in English alphabet and we need to find any means 10 or 20, 10 or 12 letters spelling or any name, then how many all possible spellings can have out of these? For example, I tell you, wait a minute, we are going to start. For example, if we have 9 digits like 0 to 1 2 3 4 5 6 7 8 9 digits, there are 9 digits. If we need to find 6 digits pin code, any 6 digit pin code, then how many all possible pin codes can be formed by using these 9 digits? So this formula to find such kind of arrangements, and we say that permutation. Permutation means number of arrangements, as we have discussed some time ago, right? Number of arrangements. And we can find is the total number of arrangement by using this formula. In some book, you can see this NPR, or this is also denoted by NP like this R, or in some book, in latest book, you'll see NPR like this. These are the same thing, okay? And formula is the same, means number of permutation can be find by using this formula. And NPR is factorial n over factorial n minus r. Okay, so do if we need to find similarly by using this certain information, means we have 9 digits and we need to find any 5 or 6 digit pin code or code simply, or any number. Okay, then how many total pin or code can be formed by using these? So take n means total, n is total number of digits means ki 9, and r taken together. We are taking 6 digit, means 6 digit pin code. So take here 6 together. So now find the number of arrangement. 9p6 is equal to, use this formula, factorial n means ki factorial 9. Here factorial upon n minus r, upon n minus r. It means ki 9 minus 6. So we have now factorial 9 over factorial 3. So let us find factorial value of 9. 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And you can take this also 3 factorial, okay? 3 factorial. So you can cut this, or you can use this 3 factorial like this, 3 into 2 into 1. So 3 gives us 3, 2 with 2, and 1 is with 1. So now we have 9 into 8 into 7 into 6 into 5 into 4. There is no need to find this all product if there is no specific reason, and you can use your calculator, right? Calculator is allowed, right?
Yes, ma'am.
Yes, so you can find it by using calculator. If calculator is not allowed, then you can
It's
mm,
allowed.
yeah, so you can find it by using calculator. So this is a number of pin code by using 6 digits out of 10. Okay. So now similarly, if you have some letters like vowels, take vowels A, O, and U, and we need to form words by using four or three or two letters. Okay, so there are five. Okay, so total are five, and we are taking four together. Now let us find number of words can be formed by using 4 out of 5. Okay. So we can find 5 p 4 is equal to factorial 5 over factorial 5 minus 4 factorial. So factorial 5 upon factorial 1. So value of factorial 1 is 1. I told you. So let us find 5 into 4 into 3 into 2 into 1 over 1 into only 1. So there are 120 words can be formed, okay, of factorial 5. Got it?
Yes, ma'am.
So this is way to find permutation, or you can say number of arrangements. Now let us understand combination. Combination means number of groups, not arrangements, because in arrangement we need mm, to consider order. Okay, and there is no need to consider an order to form a group. You can some simple take for example, we have 10% and we need to make groups of 6 people. So how many total number of groups can be formed, right? So there is no need to take an order to form a group of people, but we need to take order to find a pin code like this. We need to arrange like this. And in but in permutation there's no need to like this, means number of peoples in first person, second person, there is no need to put in order. Okay, just taking in group, in combination. But in permutation we need to consider group, sorry, order. Okay, so keep in mind that in permutation order is mandatory, but in combination only group are formed. Okay, only groups are formed. So let us understand to find number of combination or group combination. Combination formula. It is denoted by either NCR, NCR, or NCR. These are the same, but denotations are different. In some book, they use this formula. In some book, they are using this and some of this. Okay. So formula is factorial n over factorial r into factorial n minus r. This is. So as we have discussed, an example, take 10 people means n is 10, and we need to form group of 6 people means take r is 6. So now number of groups or number of combination can be found by using this formula. So tan c 6 is equal to factorial 10 over factorial 6 into factorial 10 minus 6 by using this formula. Okay, so now factorial 10, here factorial 6, and here factorial 4. So let us open 10 into 9 into 8 into 7. In next value is for factorial 6. Next we will do 5, 6 into 5 into 4 into 2 into 1, that is factorial 6. So just open till to factorial 6 because we have in denominator, then we can simply cut it. Okay, and factorial 4, let's open it. So this is the shortcut way to cancel factorial values in numerator and denominator. Just open till, if you have large value in denominator, just open this factorial till to as denominator. Got it? Means we have factorial 6 here. Just open till to factorial 6. And now open factorial 4 here. Then 4 into 3 into 2 into 1. Then now cancel it, and here 2, 2 into 4, 2 4s are 8 is cancelled, and 3 1s are 3 3s are, and rest of we have 10 10 3 and 7. Okay, so 10 into 3 into 7, so we have this. So there are number of groups of 6 people out of 10. Got it? Hello?
Yes, ma'am. Yes, ma'am.
Do you want to ask anything?
Nothing, ma'am.
Okay. Shall we do distribution tomorrow?
Yes, ma'am.
Okay. So, okay, yeah, sure. We'll do distribution tomorrow and we'll finish it max to max by tomorrow or day after tomorrow. And sure that we'll finish our syllabus and in this end of the week, I think so. It may take 1 2 days more. Otherwise, if we'll do till to end of the week, then we'll finish it easily. Okay.
Okay.
And after that, we'll do practice session. I mean, some days in a week, no, not regularly. For example, 2 or 3 days in a week. Okay, like exam like
Okay.
session to practice and to doubts. Okay,
Okay.
so let's do rest of tomorrow. Okay, all right.